Hi, welcome to my video on double angle formula for sine number 3, proving identities. Prove number 1, sine of 2 theta over 1 minus sine squared equals 2 tan theta. As in all identities, we have a left side, which is the sine of 2 theta all over 1 subtract sine squared, and we have a right side which is 2 tan theta, and it looks like this is the harder side to work out, so let's work this side out to be here, and this is 2 times tan theta, so tan theta is sine over cos, so it's 2 sine over cos is what I'm looking for. So let's start. Sine 2 theta is 2 sine theta cos theta. That's the cos of 2 theta. That's the formula. And we have 1 minus sine squared is a cos squared. So that's cos squared theta. And notice that the cos theta and cos squared theta, they cancel out 1, and this becomes cos theta. So that's 2 sine theta over cos theta, which is 2 sine theta over cos theta is tan theta. And we have it, since the left side equals the right side, it is an identity. Number 2, again we have an identity. So we have a left side, which is, the left side is the sine of 2 theta, and we have the right side, which is all of this, and I'll just write it down and you see what's there. So the more difficult, this is the easier one, so sine 2 theta is the same as 2 sine theta cos theta, so that's easy, but this is the one we have to work out. So what do? Well, we have brackets, but inside the brackets, notice that I see a 2 common, so I take the 2 out, and I have a cos squared plus sine squared when I factor the 2 out. And I have, again, sine is 2, sine 2 theta is sine theta cos theta, so I'm looking for sine and causes, so we change tan to sine theta over cos theta. And we have secant, there's no secant here, but the reciprocal of secant squared is, secant is a cos squared. Okay, so how does that help us? And in this one, I have a cos on the bottom, cos squared on the top. So again, the cos cancel out. So it cancels out the square, we get a cos theta. And we have cos squared plus sine squared, the fundamental identity, that's 1. So we have 1 from here, and we have a sine theta cos theta. And 2 times 1 is 2, so that's 2 sine theta cos theta. And 2 sine theta cos theta is the same as sine 2 theta. And again, the left side equals the right side. So write down the statement. Since the left side equals the right side, it is an identity. Okay, that's 2 done. Again, we're using sine 2 theta is 2 sine theta cos theta. Just some proofs on that. Now we have another one. This time we have logs. Again, we have a left side, and this is the left side. I'll just write it down. Half log 4 log sine A, log cos A. And we have a right side, which is the log of sine 2A. And it looks like the more difficult side is the left side. So let's work the left side down. Now we have logs. We have to know the log rules from the unit on logarithmic functions. And one rule is that if you have a number in front of a log, use it to a power. So that's the log of 4 to the 1/2, and I'll do that first. And again, I'm working the left side because this is more information in here to work through to get to here. And the sine 2A is the same as 2 sine A cos A. So I'm looking for 2 sine A cos A here. And 4 to the 1/2, go down here. 4 to the 1/2 is the same as the square root of 4, which is 2, or 4 to the 1/2 could be 4 is 2 squared to the 1/2. We have a power of a power, so they cancel. I get 2 to the 1, which is 2. So that's the log of 2. So let's simplify that first, because I always do the power rule first. Any number in front of a log, move it up to a power. Now we have the log, the sum of logs, and the sum of the logs is the log of the products. So we have a 2 times sine A times cos A. So that's the log of, altogether, 2 sine A cos A. Just to write it out, I could have left out the brackets and did just that. And what we have is, that's a log. So sine 2A is 2 sine A cos A is the same as the sine of 2A. And again, the left side equals the right side. So since the left side equals the right side, it is an identity. More dots and I's there. That brings us to some proofs, proving identities using the double angle formula for sine. Again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.